you have some information here and it asks you to find discharge in one pump, if the pump is two pump in series, if the pumps is two pump in parallel. That's the question. You will say that, okay, it gives me the discharge, but it's a range of discharge. I will ask you to give me the best possible discharge. I will start writing the Bernoulli probably for you. It says that determine the head curve for this pipeline. And then we will work on the rest. This is all the information that I have. I listed them for myself. Elevation of A, elevation of B, length of the pipe, diameter of the pipe, E, which is roughness, K for this valve, this entrance, and this exit. Because if you double check, the minors are just these three: entrance, exit, valve. That's the new, probably you need it for Reynolds, Q, E, and H for one pump, two pump in series and parallel. I will start writing the Bernoulli for you. EA plus H of pump equal to energy at point 2, which is B, because I'm going to work on A and B, plus all the losses here. I will keep HP here, EB minus EA plus HL. Instead of this one, if you remember, we can replace it with HS plus HL. Instead of HL, I like to replace it with minor, major, if you remember. And to be easier, I will keep velocity out of these parentheses. So HS is equal to H, or let's say EB minus EA. Or I can say PB over gamma plus V square B over 2G plus ZB. PA, velocity at point A, ZA. 0, 0, 0, all because of this is reservoir. So I have ZB, or elevation at point B, minus elevation at point A. If I do that, I will end it up 90 minus 80, which is 10 meter. So you have your HS. What else can you find? You have L here, you have the diameter. F, probably you have some idea that it's challenging, so you should use Moody chart. For all case, I can calculate that one because probably you need it. I have 3 different case here: valve, entrance, and exit, which is 0 point, not 0 point, actually 1.65. I think we need it at some point, so I'm going to just write these information. For online, if you are working right now with me, you can open the file that students are working under module 4, because this example is for module 4, and you have the date of the class. And if you are watching it later, if I were you, I will download that and step by step working at the same time. This is all I have. I think I put everything that I have here. I don't want to put L and D here, because if I do that, I don't have F, I don't have velocity. So that makes the case not very helpful, because still I have some problems. So instead, I will make a table for myself, the one that you have here. So I will ask you to do the same as well. This is the one that I just wrote for you. And this is the one that I will ask you to start filling. How this table came from, actually, it's not like instruction that they gave me. I made it for myself because I don't want to make mistake. I know that for each discharge, I have different velocities, which means that I have different losses. So I don't want to make mistake. I will create something like that. Discharge, the problem says that choose these discharges, right? If you remember this one given to me. So at the end, I want to find F for each discharge. And if I start writing one by one, for sure, not for sure, but probably I will have mistake. So I will make some mid steps. I will ask you to find them here. But since it's time taking, probably I will give you each one task. For example, Isabella, you go for 100 liter per second. Tanner goes for 300. Just find velocity and Reynolds and F and this. And I think I need you to give me these numbers. Tracy, 500. Garrett, 700. You again, because I don't trust them. So I want to make sure that you do it twice. 100. You 300. 500. Who is the 700? Okay. You should be careful because you are the only one who calculate the 700 because for each of them I have two groups. Or maybe I can ask Ryan to do the 700 thing. Velocity first, Reynolds then, F, E over D. So on lines, if you are working with me, you can go for 700. Be fast. For this one, you have just one number, right? We just calculate that. So that's 10 meter.
Oh, yeah.
And this one. I need you to give me this. So this is 0, 0, 0, 0, 10 plus 0, which is 10.
Oh. Oh, yeah. Oh, well. Three.
Any of you did find E over D, the relative roughness, or not yet?
3 times 10 to the negative 40.
40, 4, what did you say? 0.0004?
No, it's like 0.0003.
3, okay.
Yeah.
Do you have the same? Because this one should be the same for all of you. The diameter is the same, the pipe is the same. So this is done, this is done. Okay. And in case that you find your number, just let me know so I can write it down here in the table.
Yeah. Very-
For 100 groups, what's the velocity? I think you were 100.
4796.
Is it a good number?
Yeah.
What was the other 100? Yeah, do you have the same? For 300.
We had, 2.39 meters per second.
The other 300, I think Tyler was the 300 one, right? Do you have the same velocity? Double check, and in case that is not correct, let me know. 500, Garrett, what's your velocity?
That's 7,
What's your velocity? Oh, we don't
uh,
know.
5.57.
5.57 and 3.98 or what? In case that you don't have same numbers, let me know because I should double check the numbers. Just for your group. Reynolds for 100. You just need to give me the number which is multiplied by 10 power to 5. So skip that part, give me the number before that. Craig, do you have your Reynolds? Isabella, do you have the same for Reynolds? Okay.
We had 7.29. Yeah.
Levi, what's your Reynolds?
1.15.
What?
What?
What was the number?
1.215.
Tracy, do you have the same?
That's
The same. So now you have Reynolds, you have E over D. Go and find F. If you like to use this one, use Moody diagram. In case if you are not okay finding that, I will use online sources sometimes. There are some websites you just insert Reynolds and E over D and you will find F. I think Tanner has the F for 300, right? Online, if you see anything wrong with 700, let me know. Do you have your F or not yet?
Oh,
F.
our,
0.0515. Tracy should double check that. For 300, any available F that you can give it to me?
you said, 0.016.
Back to me, and I have this one. Brock, 100 for F. One what after that? Just one? 4 you have? I don't have 4. Very close, but it's not the same. Isabella, do you have your F right now for 100 or not yet?
We have 0.016.
You have 6. Why you're different? You have different numbers. You have 1, 4. They have 1, 6. Right. And for 700, Garrett, do you have the F?
0.01. 0.15.
Probably because the Reynolds is small for you, 2 groups. You have like close, but not the same. The one that I have is 1, 7. You have 1, 4. They have 1, 6. It's okay. It's okay. And the last one is HF. If you have your HF, just let me know your HF.
We have 1.66. Or 300.
I don't have the same. For 300, 1.66, you says? Double check it. Cooper, what about 500 one?
10.415.
I think good. 10 point, I think I have the same 10.7, which is okay, right? So it goes for this one because if you remember, this is HF plus HS. So you just need to add 10 to that one. 700, Garrett? $21, yeah, good. I just need 100 and 300 one. Martin, 300. Do you have a new number for me?
Yeah, we have 3.96.
Good. That's the correct one. I will go for 4, which gives me 14 here. I just need the number for 100 from either Craig or the girl groups.
Point 465.
0.5. And yes, if you have the same, that's correct. Plus 10, it's this one. So the table is almost done. Okay. Now, still you don't have the answer. You need to have the discharge. And you have this discharge plus the data that you have, which gives you, I assume that you fill the table, right? Here is the table, the complete table. I didn't write HF for you because if you decrease 10 from each of them, you will find the HF. That's easy. Here is the one that manufacturer gives to you. Look at here, you have for 2 pumps in parallel and series and 1 pump. Now, I want you to draw your graph based on Q and HS. This is the one. This is your characteristic curve. Find this line for me and matching point with this guy, and this guy gives you your Q for each of them. Let's start with the first one. First of all, let's start finding the point. For example, I have 0 here and 10. So 0 discharge, 10 SH, which is here. So my first point is here. Second, I have 100 and I have 1.5, which I'm going to do that. Continue with the rest. The 2 column that I just circled for you. For example, the third one is 314, somewhere here probably. And I start connecting those dots. $500 is 20. Okay, probably here for 500. 700 is 31 here, right? So probably you have something like this. Find the match point between this one and one single pump. One single pump is this one, right? Here, or let me show it by something else. Here. Find the match point and give me the discharge for one single pump. What's your matching point? Maybe I didn't draw it very well, but try to be as concise as you can. So I didn't do anything. I just make a line based on the data that I have here and here. And I find the match point for one pump, because the first one says for one pump, second for two parallel, two series. First step, one pump. Did you find the discharge?
Oh,
You draw this one, find the matching point with the red line. Why red line? Because the red line says one pump. It's not from me, the manufacturer give it to you. What's your discharge? 410 is a good one. What else? You are close, but mine is a bit different, but it's acceptable. Do you have the same or no? So maybe this one is better to show you. The yellow one is the one that I expect you to draw based on this line and this one. Okay? This one is given to you based on, where's the one pump? Here. You don't need to do anything with that. This is given to you. Just find the match point. Now, I'm asking you to find the match point for two parallel, two series. This is your line, two series, two parallel. Just find the intersection and give me the discharge for two parallel, two series. Your face doesn't show that, like, it's clear to you. I didn't, there's something here. I did nothing with that. The problem gave it to me. The only thing that I draw is the yellow line. How this is given to me, I did the best and it took me like 15 minutes to find this. So draw these two columns, which gives me the yellow line. I'm done. I just need to read about what the intersection between my line, one. It says one pump. Can you see that? So if you read this number, as Tanner said, is 420, 410. Now I'm going to ask you, what about two pump in series? This is the line that they give me. And this is again my line. I won't change my line. My line is the one that I find it. So find the intersection between these two, which is point B. So this is for two series. Do the same for two parallel. This is the line for two parallel. Don't change your yellow line. Keep that one. Find the intersection between these two. You need to find three intersections. Your line, one pump. Your line, two series. Your line, two parallel. You already gave me the one line, one pump, and your line, which is 420 liter per second. Two series, two parallel. Can you read these numbers as well? What was that? 480, 490 for parallel or series? 480, let's say, liter per second. And what about the parallel? 610, maybe a liter per second. If you have at least close to that one, that's fine. Now I think it's best to show you this one. Here, I show it by different color. Again, yellow line is your line. This is your pumps in series in red, which he says, I think 460, 470 is acceptable. And for two parallel, you have the green line, which is, he says 610, 590, 600 is acceptable. That's all you can do. So make the yellow line. The rest is just finding the intersections. You don't need to do anything. Your line, one pump. Your line, two series. Your line, three. Whatever it asks. For the efficiency, I'm not going through that. You can read the number from efficiency line. This one. You can just read it easily as well.